This video is about standards, academic standards, and how to design lessons and assessments to meet those standards. I'm talking about the standards from Oregon, which are common core standards related to circles. These are part of the geometry curriculum. All right, let's jump into it. So this is the geometry overview from the Oregon math curriculum standards. Okay, and you can see they talk about congruence, similarity, etc. So here's about circles. So basically there's two big ideas according to them, which are understand and apply theorems about circles and find arc length in areas of sectors of circles. I have my own big ideas. We'll come back to those later. Okay, now if you want a little bit more detail, this is the detailed standards related to circles. Okay, so we have number 1, prove that all circles are similar. Number 2, identify and describe relationships among inscribed angles, radii, and chords, etc. Number 3, construct the inscribed and circumscribed circles of a triangle. Okay, and number 4, construct a tangent line from a point outside a given circle to the circle. Number 5, derive using similarity the fact that the length of the arc intercepted by an angle is proportional to the radius. And I'll explain what that means as well. Okay, now, these are principles of mathematical practice. In other words, things that students should be doing throughout the whole math course of geometry, algebra, etc. Okay, so number 1, make sense of problems and persevere. So, as a teacher, you can't just give easy problems, right? Number 2, reason abstractly and quantitatively. So they should be able to do things like proofs, identify relationships, that's the abstract part, and then they should be able to make calculations, that's the quantitative part. I'm not going to go through all of these. They're on the Oregon Department of Education website. Okay, now let's talk about my big ideas. In making this unit my own, I came up with 3 big ideas for the unit on circles. Number 1, all circles are similar. That's interesting. Okay, we'll talk more about that in a minute. Number 2, angles and lines connected to circles follow specific rules. These are the theorems that were mentioned in the academic standards. We'll talk about that too. Number 3, equations about circle size always include pi. Anyone who works with math pretty much always loves pi. Okay, and this is pi, the letter pi made from the digits of pi. And do you know who decided that it was going to be pi? Well, originally pi just stood for periphery, or the Greek word sounding like periphery, which means circumference of a circle. And mathematicians used pi divided by delta to mean periphery divided by the diameter. But then later, somebody realized, okay, pi is so important, let's just give it its own letter, okay? And Euler was a mathematician who did this, and he wrote a lot of books that became famous, and because other mathematicians followed him, people started to follow the example of using pi for the number 3.1415925, etc., right? By the way, pi is an irrational and transcendent number. Okay, let's do some examples. What are some rules about circles? What can you learn about a circle? Okay, so here's an example. Let's say I have these 2 chords which intersect in the middle of the circle. So what can I say about this angle here from the intersection of these 2 chords? Well, if I take the angle of this arc and the angle of this arc, and then I add them together, divide by 2, that's going to be this angle. It's also going to be this angle because these are 2 vertical angles. They must be the same angle. Okay, so these are some of the rules that students should learn about angles and circles and chords and lines and stuff like that. Let's also talk about why all circles are similar. Okay, here we have a circle. We know what a circle looks like. In fact, all circles can be described by 2 things: the center of the circle and the radius of the circle. The center of the circle says this is where the circle is. The radius says this is how big it is. Once you know those two things, you know everything about the circle. It's very simple. Okay? But there are some rules about like angles and stuff which make it a little bit more complicated. But the circle itself is very, very simple. Okay, now, moving beyond the big ideas, there's also some important questions. We call these essential questions. I came up with 2 essential questions about circles. Number 1, what makes circles special? I have my own answer to this, but you, or really my students, should think of your own answer. Okay? Number 2, what do you need to know in order to find the measures of angles and line segments in or connected to circles? Okay, this is why studying circles might be difficult. You don't just need to know the radius and the center, but what if there's a line inside of the circle? What if there's an angle? How do I find the length of the line or the measurement of the angle? Okay, what do I need to know in order to find that information? Okay, skills. If we look back at the standards, these are the skills that are listed. Identify, prove, describe, construct, derive. Okay? These are all the things that students should be able to do about circles, which are basically the same things they do for all the units of geometry. Let's take an example. Okay, so if I give you this circle, I say this segment here is a diameter, this segment is perpendicular to the diameter. What's the relationship between this segment here and this segment? Now you should be able to say that these 2 segments are congruent because these 2 triangles must be congruent, because if this segment is perpendicular to the diameter, therefore this segment and this segment are congruent, therefore these 2 triangles are congruent, therefore these 2 line segments are also congruent. This is an example of identification, and also the student should be able to explain or describe why that's true. Okay, now this is just for fun. Did you know that pi, the number pi, is also known as Archimedes' constant? This is Archimedes. He's famous for saying, if you give me a lever, I can move the world. I like this picture because it has Archimedes, a lever, and also a circle. Pi is the circle constant. It's also Archimedes' constant. It's called Archimedes' constant because Archimedes discovered, or he narrowed down the range for pi. He was able to find out that pi, and give me a minute here, I'm going to have to look it up. Pi, by calculating the perimeters of these polygons, Archimedes proved that pi is between 223 divided by 71, or 223 divided by 71, and 22/7. This is the range that pi must be in the middle of. For a long time, that was one of the best measurements of pi. That quote is from Wikipedia, by the way. So therefore, we call pi Archimedes' constant sometimes. This is the method that Archimedes used for calculating pi. He put polygons inside of circles, calculated the perimeters of polygons, and then he said, well, the circle must have a bigger perimeter than the polygon, so the polygon is the smallest part. He also put a polygon outside of the circle and said that will be the ceiling, right? So then by making the ceiling smaller and the floor bigger, you can narrow the window that pi must be in. This is a potential project that students can do if they're interested in math, or they just like circles, like me. Potentially for extra credit, or just for fun and extra investigation. Okay, finally, assessment. So for any unit, we're going to have formative and summative assessment. The summative assessment is going to be a test. I'm going to have questions on it, as usual. And the formative assessment could be different things, but in general, formative assessment is homework. Students are going to do homework, and then I'll talk about the homework, let them know what they did right or wrong. This can help them hone their skills and get ready for the test. Okay, let's just do one problem as an example. If this segment is the diameter, this segment is a chord inside of the circle. What is this angle? Well, it must be half of this arc, right? That's one of the properties of inscribed angles. Can you prove it? Okay, so this might be one of the questions that I ask my students on the test. How do you prove that this angle is half of this arc? I'll just give you a hint. It involves isosceles triangles, but I can't really go into detail right now. All right, now to finish off, thanks for the people who created the pictures. I got the Archimedes picture from Wikimedia and the pie picture from Pixabay from a guy named iTop. All right, I guess that's it. Thank you for watching.